If you've been watching these little how-to videos, then you'd know so far we can take an equation and graph it. We can identify an equation from a graph. And then we were looking at parallel lines. So if you were given a line and then another random point and asked to create the equation, we could do that using the same gradient. But this time we're being asked to see if we can identify a perpendicular line. Now, a perpendicular line is one that is at right angles to your line. So that will look something like this. And it's very similar to finding a parallel line. The first thing we need to do is find what the equation of the original line is. So in this case, the original line will follow the same rules as all the others, so it'll be a y equals mx plus c. And so we go looking for the c value first, the y-intercept, which is at -2. So far our line reads mx minus 2. And then we'll go looking for our gradient. The way that we do that is to count. So we've got a rise of 1, 2 over a run of 1, 2, 3, 4, 5, 6, 7. Okay. So we've got 2 over 7x minus 2. Great, we've got our first line. Now, what I want to do for the second one is my new line, quite similarly to when I was doing parallel lines, is I'm going to start to generate my formula. It'll follow the rules y equals mx plus c, but we know what the gradient will be. It's not the same like it was in parallel. What we do is we flip it upside down. So instead of 2 over 7, it becomes 7 over 2. And because it was positive, it is now negative, which makes sense because remember that perpendicular line went down this way. So it would show a negative trend. All right, let's keep going. But we still don't know what the c value is. Now, what we could potentially do is we could potentially count for the gradient. But this is a great example of when this won't work, okay? Because if you have a look at this, it would go 1, 2, 3, 4, 5, 6, 7, and then left 1, 2. So we could kind of guess that it went through at 11, but that's not really a good way of showing it, if you like. So we know it's probably going to be y equals minus 7 over 2x plus 11. But what we'll need to do instead is we'll need to use the coordinates of the point A like we did last time. So have a look at point A and have a look at what the coordinates are. It's when x is 2, y is 4. And what we'll have to do is we'll have to substitute these in. So at this stage we're missing a y value, an x value and a c value. We can replace the y and the c with the coordinate values. It can be any point on the line. So y has become 4. We've got minus 7 over 2. X has become 2. And c is unknown. Again, when you're multiplying fractions, make that integer a fraction, just makes it a bit simpler. So now we're looking at minus 7 times 2, minus 14 on 2, plus c. All right, keep going. Balance method, add 7 to both sides. C is 11. And then go back to where you were forming your equation for your new line. You've got your gradient and your c value now, so your final answer is y equals minus 7 over 2x plus 11, and that one's solved. Let's do the other one. Maybe pause me now, have a go at doing it yourself and check that you've got it right. The original line will follow the rule y equals mx plus c. Let's go looking for the c value. Passes through at minus 5. So far this one is y equals something x minus 5. Let's go looking for the gradient. I want 2 points I feel confident in. A rise of 1, 2, 3, 4, 5 over -1. You might notice that I've, written that gradient in as a fraction. There's a reason for that. It'll make it easier for me to flip it upside down. I keep writing the wrong thing while I'm trying to talk to you. Try that. Right, so our equation to the original line is y equals minus 5x minus 5. Remember, if you're struggling to work out why I got 5 over minus 1, it's because I rose 5 positive positions, but then I moved left 1 negative position. The other way to think about this is you can just have a look at that line, and that line shows a negative trend running down, so you know that line should be negative. Let's keep going. We've got a new line. Our new line will be y equals, and instead of 5 over 1, it will be 1 over 5x, and it will be positive because it originally was negative, and we don't know what our c value is. Now what we could do is we could try and cheat, and we could try taking our point and doing a rise of 1 over a run of 5, or maybe we could try dropping 1 and running 5. We'll definitely miss the line this time, so there's no cheats way of doing this one. What we'll have to do is take the coordinates. So we've got the coordinates 3 minus 4 by the look of it. 1, 2, 3, 4. And what we'll do is we'll replace the x and the y in our new line with those coordinates. So y becomes minus 4, x becomes 3. You might notice by now I like to make that number a fraction just to make multiplying my fractions a little easier. This time I've got minus 4 equals 3/5 plus c. Some of you guys are going to be stronger at working with fractions than others, and some of you will be doing a calculator and a non-calculator test. So let's assume we're doing a non-calculator test. Some people will see that when we subtract 3/5 here, we'll end up with -4 3/5. If not, what you could do is you could convert this to -20/5, okay, so that we're all working in fifths. And then when you add 3/5 to both sides, also you're taking 3/5 from both sides, you'll end up with -23/5. Either way, it'll get you to the answer. Once you've managed to work out that c is 23/5, you go back to the equation that you're building here. You go y equals 1/5 of x minus 23/5. And this one's been answered as well.